Welcome to classful addressing. So what is classful addressing? Classful addressing is the process of grouping IP version 4 addresses into various class groups based on a fixed subnet mask with host and network portions, and also based on the first octet. Initially, classful addressing was the standard for identifying IP version 4 address groups, but it is quite inefficient and wasteful. Today we use classless addressing instead. So there are 5 classifications of classful addressing as seen below. So the first class we have is class A, with the first octet ranging from 0 to 127, as we can see here, and a subnet mask with the first octet being all ones, which means that the first octet is the network portion. And we can also see the subnet mask notation as /8, which means the first 8 bits are all ones. Then next we have class B, which ranges from 128 to 191, which means that the first octet of the IP address must fall within 128 to 191, and the subnet mask portion has the first 2 octets as all ones, which means the first 2 octets are the network portions, with a subnet mask notation of /16, which means the first 16 bits are all ones. And we have class C, which has the first octet of the IP address fall between 192 to 223, and we can also see the subnet mask has the first 3 octets as all ones, which means the first 3 portions of the IP address are the network portions, and we can see it here as /24, meaning that the first 24 bits are the network bits. And we have class D and class E, which are not usually assigned to devices. They are used for multicasting and experimental use, and the IP version 4 first octet ranges between 224 to 239 and 240 to 255, and we can see that all parts of the IP address is the network portion. That's why we have /32, which indicates that all the 32 bits are the network bits. So these are the 5 classes we have for the IP version 4 address using classful addressing. So let's look at an example of this. So over here we have a class A IP address, which is identified. Remember when we explained what classful addressing is, we said we use 2 things to identify within an IP address. The first one is it has a fixed subnet mask. That means either the first portion or the first and second or the first 3 or all the portions of the IP address bits are all ones. And we also see the second condition is the first octet number. So does it fall within a certain range for class A, class B, class C, class D, and class E? So in this case we have 10, which falls in the range of 0 to 127. So we can see that by looking at this, we already find that this is a class A address using the classful addressing. And we can also confirm that the subnet mask has the first 8 bits as all ones. That is why it's 255. So meaning that this first portion or first octet is the network portion, as we can see here, the first 8 bits and 255 for the first octet. So that's why this one is identified as a class A IP address. So how do we now memorize all the 5 classes where the first octet number starts from and ends from? So we can use the decimal to binary conversion table to easily achieve that. So remember that we had 2 raised to the powers for each of the IP bits for the first octet, and we can see that we have the numbers 128, 64, 32, 16, 8, 4, 2, 1 derived from this 2 raised to the powers. And that was what we used to convert our decimal to our binary, as we can see here. So in the same way, we identify class A addresses as any IP address that comes just before the first bit is turned to 1 while the others are off. In other words, anything before the 128. So in this case, we can see that the first column has 1, which is turned on, and the rest is all zeros. So that's the first bit. So that's the class A range from 0 to 127, which is just before the 128, which is the first column turned 1 and the rest zeros. And the same thing with class B, we can see that the first 2 columns are turned on and all the rest zeros. So anything before that and starting from the one with the first column as 1 and the rest 0 is class B. So that's 128 to 191, and the next one after that is 192. And the same with class C, we can see that the first 3 columns, which is we have 111, is 224. So anything that falls before that and falls after the 129, which we got from previous table, where the first 2 columns are on, is class C. So we can use this to identify that class C ranges from where we have the first 2 columns as 1s to just before we have the first 3 columns as 1s. And how do you achieve this 192 in this case? It's simply 128 plus 64, which gives 192. And in this case is 128 plus 64 plus 32, which are the turned on bits, which gives 224. So we can easily identify also class D has the first 4 columns on, which means 240. Anything before 240 and starting from 22 with the first 3 bits on is class D. And class E is the same thing, but this time starting from 240 down to 255, which is the end of the IP table. So we can see that we can easily identify these as key numbers. That's 0, 128, 192, 224, 240, and 25, just by simply adding these values at the top. So for class A, we have 0 to 128, which is the first column. Class B, we have 128 to 192. Then class C, we have 192 to 224, which is the first 3 columns as on. So 128 plus 64 plus 32 is 224. Class D is 128 plus 64 plus 32 plus 16, which is 240. So 224 to 240. And class E is 240 to 255. So that's simply how we can easily memorize the IP class ranges. So let's try our hands on this and see if we can address these IP addresses into classes. So it says, what classful addressing groups do these IP version 4 addresses belong to? So looking at the first one, we can see that the first octet is 19. And remember that our IP address ranges starts from 0 to 128, which is class A, 128 to 192, which is class B, 192 to 224, which is class C, 224 to 240, which is class D, and 240 to 255, which is class E. And in this case, we have 19, which falls within 0 to 128. So this class group should be class A. That's right. And the subnet mask we will have is, remember, for class A, is the first octets are the network portions, all ones. So we have 255.20.0.0. And the subnet notation says that the first 8 bits are all ones, which are all on. meaning they are the network portion. So we should have /8. And if we look at this table, it gives us an idea of how to achieve that. We can see that class A starts from 0 to 128, class B starts from 128 to 192, class C 192 to 224, class D 224 to 240, and class E 240 to 255. So in this case, we have 19, which falls between 0 to 128. So that should be class A. And that's what we have here. Class A, subnet mask 255, 0.0.0, and we have /8, which is the first 8 bits are all 1. So let's try our hands on this next one, 252.10.5.2. So what class group is this? And the subnet mask and subnet notation. So you can pause the video and try your hands and see if you get it. So we use the same method, and that is 252 falls between what IP first octet range, and we can see that it actually falls between the last range, which is 240 to 255. So we can easily identify this as a class C E IP address, and that's what we have here. Class E, you can see that all the IP address bits are all ones, which means is used for experimental use, and all of it is the network portion, and we can see the subnet mask notation is 32. All the 32 bits are all ones. So let's try this 250.7.50. So where does 200 fall within what IP first octet IP range? And we can start with our IP addressing table, and we can see that 0 to 128, which is class A, 128 to 192 class B, and guess what, 192 to 224, which is class C, and 200 falls between 192 to 224. So this is a class C address, classful address, and we can see that here, class C, and we can see the subnet notation /24, which identifies that. So what about 130.4.8.20? What class is that identified in? And let's start the same thing, 0 to 128, 128 to 192. So this looks more like a class B address. Why? Because 130 falls between 128 and 192. So we have it here, class B, which is 255.255 subnet mask, meaning the first two octets are all ones, and /16, meaning that the first 16 bits are all ones. And finally, we have 230.9.9.10. Where does 230 fall into? So we have 0 to 128, 128 to 192, 192 to 224, and we have 224 to 240, and we can see that 230 falls between 224 to 240, which is class D, and we can see the result here, class D, which is for multicasting and has all the subnet mask as all ones, and we have subnet notation of /32. So this is simply the way to classify IP addresses using classful addressing.